Hello students. So in today's video we are going to see what is copy structure, right? So this is continuation of the structure chapter. So now this copy structure, we can copy the members of one structure variable, that is the structure variable such as emb1, emb2, emb3, like that, right? So these are the members. So we can copy these members of the structure variable, suppose like emb1. So emb1 members are this, and emb2 members is also same, and emb3 members are also the same, because they all belong to the structure employee. So we can copy the members of one structure variable to another structure variable as long as both structures have the same format. As long as emb1, emb2 and emb3, they all have the same format, that is, they all belong to the structure employee, and they all have these they all have these employee these members, right? So emb1 also will have the same format, that is these members. emb2 also will have these same members. emb3 also will have these same members. So according to this, it is possible that one of the structure variable members data can be copied to the other structure variables also. All right, so here in this program we declare two structure variables. All right, okay, three structure variables, but initialize only the first one with the data. So now in this particular program we are declaring three structure variables, right? But we initialize only the first structure variable, that is emb1, and then the other two structure variables are initialized when the first structure variable value is assigned to them. So after the first structure variable emb1 is assigned the values, then that value is assigned to the two structure variables, that is emb2 and emb3, right? So let's see in this program. So here as you can see that this is structure declaration. This is, now you see that this is outside of the main function. So here in between the curly braces and the semicolon, no structure variables are declared, but the structure variable is declared inside the main function. So now we initialize the structure variables emb1. So here you can see that the structure tag is employee, and so using the structure tag, because this structure tag is actually user defined data type, right, which is similar to character char emb1. all right, so employee emb1, right? So now employee emb1, so what it does is it is declaring the emb1 as a structure variable. When we write down the structure name or the structure tag, and after that the structure variable, this tells the compiler that okay, emb1 belongs to the employee structure, that is, this is a structure variable. All right, now previously in the previous program we wrote while assigning the values to the members of the structure variable, you have seen that this program code was written like this, right? emb1.emb code. Or in the other programs using the C input stream, we saw that it was assigned C in emb1.emb code, like that, right? So user entered from the keyboard. Now in the program code, the values 100 was assigned to emb code, the members of the structure, using the structure variable, using the dot operator, right? Now similarly here, what you're doing is you're actually declaring a variable. Now when you declare the variable, you are allocating memory space for the members of the structure, right? For the structure variable, then only the structure variable will access these members and assign the values to these members. So now directly using the assignment operator and within the braces, you can see that the values are entered 100 John Smith. Since this is a string, so it is enclosed within double quotes. Then designation, all right, okay, suppose like computer teacher, right? So this is designation, then this is the salary. So now you can see that here instead of assigning one value at a time, emb1 dot emb code, emb1 dot emb name, emb1 dot emb designation, emb1 dot salary, like that, right? Straight away you can see that when the structure variable is being declared, we are assigning the whole all the values using this structure variable. So it is possible so instead of writing down one line of one by one, assigning the values one by one, you can see that all the values for the members can be assigned when we declare the variables, right? So this is also possible. Okay, so this makes a shortcut work of assigning the values directly. So this is actually an explicit uh, uh, explicitly assigning the values to the members, right? So when the variable structure variable is declared, you can see that all the values are assigned directly. Okay, so now here again another two structure variables are declared, that is emb2 and emb3, using the structure tag. But here, so this is the structure variable, this is structure variable, this is structure variable, but these two structure variables are not initialized at all. They have not been assigned any values. The members of these two structure variables, that is these members, have not been assigned any value at all. So now what we do is that emb2 equals to emb1. What we do is that we copy the members of emb1 to emb2 and emb3. Right. So now when we emb1, that means all of these members, the values, we copy to emb2, and then emb1 equals to emb3. Similarly, we are copying the members of emb1 to emb3. All right. So as per the program statement that says are initialized, the two structure variables are initialized when the first structure variable is assigned to them. So this first structure variable members are assigned to emb2 and emb3. So finally in the next step we display the information details. So emb2 information, all right, and then here under the C output stream you can see that employee code is emb2 dot emb code, so emb2 dot emb name. So similarly for employee tree information, again we simply write down, we change it from emb2 dot emb3 dot emb code, right? So since the values are already assigned pre-written in the program, once you run the program you don't need to type anything at all, right? So okay, there is some error. Okay, character is too long. As you can see that designation, I have given the size as 15, but it exceeds more than 15, right? So here we can increase it to say 25. See, so now you can see that you are getting the same exact data for both emb2 and emb3. Because why? Because we have assigned the members of emb1 to emb2 and emb1 to emb3. All right. Now similarly we shall see another type, that is user defined data type, typedef. Now using this typedef we can create a new name for an existing data type, for a data type, okay, for an existing data type, using this typedef, which is an alias name. So another name given to the existing data type, a new name. So this new data type name can be used anywhere in place of the old data type name. So the format is very simple. We just use the keyword typedef. So this is actually a user defined data type, right? And this is the old name and then the new name. So the old name is actually the predefined data type or the derived data type, but the new name is a user defined new name data type, right? So here in this program you can see that small num is the new name for character data type. So here using the typedef, this is the all data type, and this is the new data type. This new data type is actually a new name for this old data type. So small num is the new name for this character data type, and it is used to declare the variable I. So in the main function you can see that small num I, right, which is similar to character I, right. So in place of this character data type writing down here, we are writing down here small num I, because using the type definition, type def, we are converting the old data type to this new data type name, right. So when you run this program, since no input stream has been given, so what will happen is that when you run this program, the compiler will generate a random garbage character value. It may be in any form. All right. Now, three things you have to remember about typedef is it does not deactivate or it does not remove the original variable. That is, or the original variable or original data type. So here, character data type is still valid, because here you are changing this character data type to small num, right? But this small num, when you write down here, it represents this character data type. So I will be of, I will store character values, right? So it does not remove the original variable or data type. Now we can use several typedef statements to create many different new names for the original type. So that means here this typedef, this character data type, it can be used with many different new names. Say like in this line you can see that the character type is mentioned as small num. In the next line we can rename it to big num or medium num also. It can be used as many times. Typedef does not create a new type of data, it only creates a new name for an existing type. Alright, so it does not create a new data type, but it is only a new name for the existing data type. So let's see these. So you can see that the same program. All right. So this small num represents this character. So here, instead of this character type, we write here small num. So when you run this program, you will see that you get a random values, character values. All right. So since you have not entered anything from the keyboard, so this is the data values that you're getting, right? Now the second point is you can use as many new names for the same types, right? So here the only changes that I've done is here again I have written type def character. So this character type, again I have created a new name, that is this big num. So here small num represents this I, big num represents this J, right? So big num J. So here when you run this again, cout I, cout J, so you get two different outputs, right? So type this program, okay, run this program, and then see what are the different types of outputs that you're getting, all these three programs. All right.